The learning target for this video is to learn how to use dimensional analysis to convert from one set of units to another, because that's typically what we're using dimensional analysis for. There are some really important terms that go along with dimensional analysis that I'll be using a lot in this video that you probably ought to know the definitions for or what I mean by them. The first one is equivalence statement. An equivalence statement is pretty much an equality, so it's going to have an equal sign where it has one number with a set of units equaling another number with another set of units. For example, 1 liter equaling 1,000 milliliters is an equivalence statement. The conversion factor relates the equivalence statement, but in kind of a fraction format. So if we have 1 liter equals 1,000 milliliters, there are always two conversion factors that can be written for every single equivalence statement. In our case, the two conversion factors are 1 liter over 1,000 milliliters, or the other way around, where we have the 1,000 milliliters on top and the 1 liter on bottom. A measurement is just something that has a number and a unit with it. For example, the 1,000 milliliters is a measurement, where 1,000 is the number and the milliliters is the unit. Whenever we're talking about units, we're just trying to describe what standard or system that we're in right now. As I mentioned in the learning target, whenever we're doing dimensional analysis, we're just converting from one unit to another using conversion factors. When we're doing dimensional analysis, especially using this train tracks method that we'll be using, what we're looking for is that the unit here matches the unit down here, or the units that are diagonal with each other. If we have a unit here, for example, that we want to get rid of, we need to make sure that the unit up here diagonal from it matches it. So the units that we're trying to get rid of, we want to make sure appear diagonal in dimensional analysis, or especially in this train tracks method of doing dimensional analysis. Whenever we're talking about multi-step dimensional analysis, we're talking about having multiple conversion factors. And when we're doing this train track style of dimensional analysis, remember that this area right here in the top left-hand part of our train tracks, this is where the given goes. And that's typically what we call it. That's the thing that's given in the problem that we're starting with. And then each one of these things here is considered a conversion factor. So whenever we have multiple conversion factors in a problem, that's a multi-step dimensional analysis problem. When doing a multi-step dimensional analysis problem, a lot of times it's easier before just heading into dimensional analysis to come up with a plan for ourselves. For example, let's pretend that we wanted to get from 89 kilometers and change that to, or figure out how many inches that is. Without knowing how many inches in a kilometer, it might be easier to come up with a plan for ourselves. What we do know is that we can go from kilometers to meters, and what we also know, hopefully, is that you can go from meters into centimeters, and then we also know, hopefully, how to get from centimeters into inches, either via table or just having memorized those conversions. In this case, this is our plan. So to get from kilometers into inches, we're going to go from kilometers to meters, and then meters to centimeters, and then centimeters to inches. So that's the way to go. Whenever we're coming up with a plan like this one, each one of these arrows represents a conversion factor. So this thing here, we're not considering an arrow because that's not part of our plan. That's what we're trying to do in the end. But we have 1, 2, 3 different conversion factors that we're going to need in order to get from 89 kilometers into inches. So let's look at what this dimensional analysis would look like. We would have 89 kilometers as our given, so that's going to be in the top left-hand box. And when we're coming up with these other boxes, remember that each one of these should be a conversion factor. So we're going to need 3 conversion factors, we decided, so we better have at least 3 boxes here. And that's pretty much all we'll need. So I'm going to go ahead and actually erase this last little bit because we won't need that. In fact, we'll change that over to an equal sign. And remember that we want units diagonal from each other to be the same. So if this is kilometers here, then we want to have kilometers there. So let's put the kilometers there, and we want to change that into meters. So I'm going to put meters on top. And because this is meters and we want to get rid of that next, we want to have meters down here. So we're going to put meters down here, and our plan says we're going to change meters into centimeters, and the last part of our plan says we're going to change centimeters into inches. So those are all of our units, and I always feel like it's easier to put these units in first and then put the numbers in. You'll notice I left a blank in front of the units here to in fact put those numbers of the equality, because remember that the top thing is equal to the bottom thing, and that's kind of our equivalent statement that was flipped on its side. So we know that in 1 kilometer there are 1,000 meters. We also know that in 1 meter there are 100 centimeters, and in 1 inch we have 2.54 centimeters, which is a conversion factor you definitely need to memorize. Now let's see if we can figure out the sig figs involved with everything. There are 2 sig figs in our given, and ones we're always going, if they're in a conversion factor, we're going to call them an infinite number of sig figs. So that's infinite number of sig figs. That one is an infinite number of sig figs. This one is an infinite number of sig figs. Now, if there was a 1 in the given, we would count that as 1 sig fig. But if a 1 is in a conversion factor, we need to count it as infinite sig figs. Now here, because meter and kilometer are in the same unit system, we're actually going to consider that other number also infinite. And again here, meters and centimeters are in the same metric system, so we're going to make that an infinite number of sig figs. By the way, when I'm talking about infinite sig figs, I'm talking about just ignoring the number of sig figs for that number. We're just not going to worry about it. So remember that the only time that we're actually counting a 1 as a sig fig is if it shows up here in the given. Otherwise, we're just counting them as infinite sig figs. Now here, because actually the way that our book suggests to handle the conversion of inches and centimeters is that we're going to consider this an exact conversion. And in exact conversions, we consider them to be like being in the same unit system, which means that that's going to be an infinite number of sig figs also. That's actually the only one of the English to metric that we're going to consider exact. So anytime we're going from centimeters to inches or inches to centimeters, we're going to consider that an exact conversion, even though technically we're going from the English system here to the metric system, which are actually different unit systems. Okay, now looking at all of these sig figs that we've put in green here, remember that the rule for multiplication and division with sig figs, we need to always use the least number of sig figs. So we're going to look at all of these numbers and figure out which is the least, and that's what we're going to round our final answer to when we finally get there. So we're comparing 2, infinity, 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 and infinity. And out of those numbers, 2 is the least. So our final answer, we better round to only 2 sig figs. Okay, so the first example on your sheet, I believe, says that we are going to try to change over 0.036 meters into inches. So we're trying to figure out how many inches that is. So if we were going to come up with a plan for this, my plan would probably be to change meters into centimeters and then centimeters into inches. And again, the fact that I have two arrows here tells me that I'm probably going to have two conversion factors to do this. We're not going to be able to do it all in one because I don't know how many inches are in a meter. So now my dimensional analysis table is going to look kind of like this, where this is one conversion factor, that's another conversion factor, and remember this area here is the given. So 0.036 meters is going to go there. We're going to end up changing the meters into centimeters, we said, and then centimeters into inches. And again, I'm putting in all the units first, and now I'm going to go back in and put in the numbers. I know that in 1 meter there is 10 to the second centimeters or 100 centimeters. And in fact, if you know this conversion slightly differently, you can put that in instead. So if we wanted to put in a 1 centimeter here and 10 to the negative second meter there, that's fine, if that's the way you know it. Or if you know it as 100 centimeters and 1 meter, that's fine. Either way is fine. I'm actually going to stick with the blue, I think. So I'm going to erase these right now. And for the centimeters to inches, there are 2.54 centimeters and 1 inch. So those are all my numbers. Now let's look at sig figs. There's 2 sig figs in 0.036. Because centimeters and meters are in the same unit system, those are going to both be infinite. And because inches and centimeters we decided before was going to be an exact conversion, these are both going to be infinite. So sig fig wise, that's infinite, that's infinite, that's infinite, and that's infinite. So out of these numbers then, 2, infinity, 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 and infinity, 2 is the least. So 2 sig figs is where we're going to round our final answer. By the way, when we're putting these things in our calculator, these dimensional analysis problems, remember that we're multiplying everything on the top and hitting divide by any number that's on the bottom, and we're skipping the ones. So in my calculator, I actually put in 0.036 times 100. I skipped this one, and then I did divided by 2.54 because I divided by this, or ignored this one. And the number I get in my calculator, because we don't want to round, is 1.41732 with a bunch of other stuff after it. And now that we know we need to round to 2 sig figs, we're going to cut this off after 2 sig figs. So our final answer here then is actually going to be 1.4 inches. And that's rounded to the proper number of sig figs with all the right dimensional analysis. You definitely should try this problem yourself in your calculator just to make sure you're getting the right answer in your calculator. The number I got in my calculator is 1.417322835, so make sure you get that number. The next example problem is quite a bit more difficult. It's asking you to go from 5.17 pounds per gallon into pounds per quart. Oops, let's see here, quart. There we go. Okay, so whenever we're going from a unit that has one unit over another, like pound over gallon, into something like another unit that looks like a fraction, what we want to make sure of is that the top unit needs to convert into that top unit. And in our case, we're not going to do anything from the top units because they're staying the same. And then the bottom unit needs to convert into the bottom unit. So really, our conversions are going to be focused on getting gallons over into quarts because pound is staying pound on the top. So gallon into... So you'll notice what's showing up now on the screen is this table here. And this table may be something I've given you on your worksheet before. And typically, my expectation of my students, both high school wise and college wise, is they know the bottom third of this table by heart. They've memorized the bottom third, and they memorized this conversion of 1 inch to 2.54 centimeters. Anything else, I would essentially give you on a test or on an assessment or something like that. I would provide for you, is what I mean by I would give you. So again, the ones that you need to know yourself without my help are these down here and this one there. The rest of them I would give you. So you'll notice here that there is one that goes from gallons to quarts. So that's going to be useful in getting that bottom unit changed. So let's go ahead and do that. That should be just a one-step process because we already have the conversion factor of gallon into quart. So now let's set up the dimensional analysis. So we know we're going to need at least one conversion factor to get us from the gallon to quart. And we know that our given is 5.17 pound per gallon. So I'm putting the pound on the top and the gallon unit on the bottom of my given. The pound we're not doing anything with, so we want to keep that the same, but this gallon we want to get rid of, and because we want to get rid of gallon, we want it to appear up here. So we're going to put gallon up there at the top, and remember, we're trying to change that to quart, so I'm going to put quart on the bottom, and looking over here at my table, I know that 1 gallon is 4 quarts, so I'm going to put 1 in front of gallon and 4 in front of quarts. And actually it looks like we don't need any of this other stuff over on the side. So I probably put too much here, and I would have normally erased that or crossed that out and just put an equal sign. Now sig fig wise, we know that that's 3 sig figs. Gallon and quarts are both in the English unit system, so that's going to be infinite. That's going to be infinite. The 1 again is infinite because it's a 1, and it's also because gallon and quart are both in the same unit system. So it looks like my final answer needs to be 3 sig figs. So in my calculator, I'm going to do 5.17 divided by 4, and I get 1.2925. And remember, I need to round this to 3 sig figs. So after rounding this to 3 sig figs, my final answer is going to be 1.29, and my final unit is going to be pound per quart. You'll notice because gallons appeared across from each other, we could cross those out, which leaves pounds on the top and leaves quart on the bottom, which is why my final answer is 1.29 pounds per quart. Okay, in my last example there, in example 3 I think it is, it says that we're trying to change 3.4 miles per hour into kilometers per minute. So this time I'm trying to change my top unit from mile to kilometer and my bottom unit from hour to minute. So as far as going from mile to kilometer, if I look back at that chart that I gave you a minute ago, which I'll put back up here in a second. So there it is now, and hopefully if you're going from mile to kilometer, you can see that we don't have a direct conversion of into mile to kilometer. We do have mile into foot. Oh, actually we do, looks like have a direct conversion of mile into kilometer. It's right there, I just didn't notice it before. So mile to kilometer is here, and because it's in the top 2/3 of this thing, that's not one I would expect you to memorize. I would actually give that to you on a test. So we're going to use mile to kilometer, so that's a one-step conversion of mile into kilometer. And then as far as hour into minute, I think we know that that's a one-step conversion because we know how many minutes are in an hour. So now let's set this up. Both are one-step conversions. So 3.4 mile over hour, so miles per hour. And then we can do the top conversion first or the bottom conversion. It doesn't really matter. You're going to get the same answer either way. I think I'm going to choose to do the top conversion first, which means I'm going to put mile down here so that this mile matches up with that mile. And it means that kilometers would be on top of that, and then I would do the bottom conversion. And the fact that hours is down here, I need to make sure I have hour diagonal. It can't be directly diagonal because we have something else there. So we're going to put a diagonal way over here. So I'm going to put hour there, and then minute. We know in 1 hour there are 60 minutes, and we know that in 1 mile there are 1.61 kilometers, and again that's based on this chart right here. So there's my dimensional analysis. Let's look at sig figs now. 3.4 is 2 sig figs, 1.61 kilometers into miles. This is 3 sig figs, and we're counting the sig figs this time because kilometers is a metric unit and miles is an English unit, so they're 2 different unit systems. But this is a 1, so we're going to go ahead and make that infinite. We're going to count hours and minutes as the same unit system. The unit system that they're both in is time. So there's exactly 60 minutes in an hour, so that's why we're going to count both of these as infinite. So if we're looking at the least number of sig figs, it looks like the least number of sig figs is 2 sig figs, which is what I'm going to round my answer to. So when I put this in my calculator, I'm going to do 3.4 times 1.61 divided by 60, and that's skipping those ones there. Alright, when I put this in my calculator, I got 0.09123 is repeating, so lots of 3's afterwards. But we need to round this to 2 sig figs. So rounding this to 2 sig figs, our final answer is going to be 0.09. And then our final unit, because these hours and those hours are going to cross out, these miles and these miles are going to cross out, we're going to have kilometers on top and minutes on bottom. So my final answer is 0.09. Oops, it looks like I just made a mistake here. If I'm getting 2 sig figs, this actually needs to be 0.091 kilometers per minute, not 0.09. So make sure you make note of that. 0.09, I screwed that up. That's just 1 sig fig, and we have to have 2 sig figs. So there is our 2 sig figs, and the final answer again is 0.091 kilometers per minute.